Greetings everyone, welcome to today's session, and we're looking into probability and choosing the right probability approach for you. Previously we did look into the types of events in probability, the independent events, the dependent events, the binomial situation, and for this particular session we'll be looking into the approaches on how we solve these probability questions. And so I'm Clifford Mwenda, a GMAT of the Kenya Life program, and without much further ado, let's jump into today's video. So the first thing is we'll be just doing a recap on what we talked about. What's probability? In an experiment where outcomes are equally likely, the probability of event E, that's denoted as P into brackets E, is the total number of outcomes in E. This is what we call the successes all over the total number of possible outcomes. And this probability of E ranges from 0 to 1 when it's certain and 0 when it's uncertain. And one thing also before we look into how to solve these probability questions is as a guide, as a general guide, OR means add and AND means multiply. So I hope that's clear. Now let's jump into the start of today's video. How do we solve these probability questions? So we'll be looking into 4 approaches. First one being the probability tree, how we use the probability tree, when we use the probability tree. Then we have the direct probability when you're dealing with proportions. We'll be talking about that as well. Then you have the complement probability or the complement rule. And lastly, we'll be looking to combinatorics as an approach to solving probability questions. And we'll be talking more about these probability questions, not questions, but the approaches that we'll be doing later on. So let's start off with probability tree. For the probability tree, it's commonly used when you have dependent events. This is the conditional events. If one event happens, it affects the other outcome, and vice versa. The other event can happen and it affects the outcome of this other event. For this one, they're great when you have to visualize your problem and draw the tree. You will be looking to a question. It's also organized in terms of its structure. Yes, it's the moment you draw the branches, you can easily visualize the problem and organize your problem pretty well. And they're very good when you're dealing with conditional probabilities. It's one of the easiest ways to approach conditional probability because you can easily follow through whatever you're doing, and they're also flexible in terms of they can be used for both complex and easy questions. But the problem comes when you have multi-stage probability questions, and they create some very big types of trees with very many branches, and therefore making it tidy, you are prone to make an error. You can also waste a lot of time with using probability tree. And so let's try a question and see how we can use probability tree to solve a probability question. Here's an example. Please pause the video, give it a try, and then I'll jump in. Okay, a box contains 3 balls and 2 blue balls, 3 red balls and 2 blue balls. You randomly draw 2 balls, one at a time without replacement. This wording here, without replacement, means we're dealing with conditional probabilities or dependent events. What is the probability that you draw a red ball first and then a blue ball? Okay, now in this case we're dealing with probability, so we can start. We have probability of picking a red for the first one and probability of picking a blue for the first one. So picking the red for the first one, you'll have 3 out of 5 balls, and blue for the first one is 2 out of 5 balls. Okay, then after picking a red, what's the probability of picking a red? And again, and what's the probability of picking a blue? That's how the tree is drawn. And after picking the blue being the first ball, what's the probability of having red ball being the second one and blue being a second choice after picking blue being the first one? So we can fill in these probabilities in an exam setting. You don't have to fill in all these probabilities. You can just go ahead and choose what you want or what you need for this particular question. So after picking a red ball being the first one, we'll have left 4 balls. Out of these 4 balls, we have already picked a red ball. Now we have 2 out of 4. That's the probability of picking a red ball being the second choice. Then picking blue ball as the second choice, we have left with 4 balls now. We have 2 red balls and 2 blue balls. Also picking a blue ball will be 2 balls out of a possible 4 balls. Then for the blue ball, after picking blue ball being the first choice, Picking the red ball being the second choice, you'll have left 3 red balls out of, you've already picked a blue ball, now you're left with 4 balls. And also we have a total of 4 balls after picking the first blue ball. That means you're left with 1 blue ball, and these are the probabilities. So you're asked what's the probability that you draw a red ball first. You draw a red ball first and then a blue ball next. So we're picking this value here and this other value here. So that's 3/5 times 2/4, 6 out of 20, which is 3 out of 10, right? And that's how you draw the probability tree. And they're very good when you're dealing with they're actually versatile. You can use them for dependent probabilities and also independent probabilities. For this particular question, we're dealing with dependent probabilities, and you can see it's structured, it is well organized. You can visualize the problem and see what really happens in this particular question. And yeah, they're good when you're dealing with a small level questions, multi-stage. In case you're told about picking, say, 5 consecutive balls, then you'll have very huge trees and very complex, giving you an easier chance of getting an error, which is very dear while doing your GMAT studies or doing your GMAT exam. So let's look into other approaches that can help you when you're dealing with very complex or big types of trees and you don't have to use the trees anymore. Now, what do we use? We use the direct probability. And for this one, the approach to direct probability is more of the formula, the one that I mentioned earlier. The success is all over the number of total outcomes or the total possibilities. And it's efficient when you can find that probability of the event E easily. This one is great for mathematical precision. They are not prone to errors as the decision tree, or not the decision tree, but the probability tree in this instance. So it's also fast in terms of calculation. Since you have the formula, yeah, you can use this for very difficult questions or easy questions, and you get to get consistent results since you have a formula that you have. But in terms of understanding the probability approach or understanding what's going on or visualizing the problem, the probability tree does a better job. But you're doing GMAT now, you need to understand what really happens, but also save up your time and efficiently do this question in less than 2 minutes or in less than 1 minute and 30 seconds, right? If it's a problem solving, if it's DS, then you need to think about a minute so that you can save your time for the other integrated reasoning questions in the data insight section. And so, how do we solve a problem using the direct probability? Let's look into an example, the same example. Now let's look at in terms of the finding the probability of this event A as a formula or as the probability without drawing the trees and branches. Okay, pause the video, give it a try, and then share your, or not share, but we'll do it together. Okay, the same question a box now contains. It contains the 3 red balls and 2 blue balls. You randomly draw 2 balls, one at a time without replacement. What is the probability that you draw a red ball first and then a blue ball? Okay, now in this case we have to use the and or rule. We want probability of red and blue later on. Now the probability of red is, we have 5 balls now. For the first choice we have 5 balls and you're picking a red ball, so the probability of picking the red ball being the first one is 3/5. And right, the probability of having the blue ball being the second one, now you're left with 4 balls after picking the first ball, and the successes here are 2 blue balls, so you can have 2 out of the total possibilities that are 4 balls. So in terms of formula, we have 3 being the successes for the red ball first and 2 being the successes for the blue ball being the second one. And so this is half, and since you have and, we said or means addition and means multiplication. we multiply whatever values we have, 3 over 5 times a half, 3 over 10. Okay, I'm using this example to show you how we approach these problems. Using these different approaches, and what you find suitable for you, you can pick and practice. But it's great to know all these tools, so that whenever a GMAT exam comes in a certain way, you can give it your best and give it your best in a short time that you have. Okay, we got the 3 over 10 again, and we didn't have to do the tree and fill in all the values. We just did the probability of picking the red ball first and then picking the blue ball second. Just finding the successes as easy as that.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
And so, besides direct probability, there is another way in terms of some wordings can change here and there, and we can use what we call the complement probability. This is when the idea behind this is what we want plus what we don't want equals to 1, right? So these are the complement probability. Finding the failures, then subtract that from the total possibility, that's 1. That's the whole probability. Then we find what we want. Okay, so it's efficient when you can find what we don't want and then subtract from the total. And it's a variant of the direct probability approach. We're still using the probability of event E approach when solving for the what we don't want, or the failures, or what we call Q in mathematical terms. Q equals to 1 minus B. And in most cases, B is the success and Q is the failures. And you have Q plus B being 1. What we don't want plus what we want equals to 1. This approach has the same pros and cons as the direct approach, since you're using the formula, you have the precision, you have the speed, you have versatility. You can get consistent results depending, since you're dealing with the formulas, and it's also good when you're dealing with complex problems, and actually saves time doing complement probability instead of direct probability when you have key terms such as at least. We'll see in an example. Then depending using, since you're dealing with this complement probability, which is a variant of direct probability, we're dealing with the formula probability of event E. That means you don't get that intuition or that deep understanding on probability, just as the probability that we did for the first example. And so let's do the example and see what happens for the complement probability. Okay, the same question now, it's just modified to see what you can get using the complement probability. Okay, a box contains 3 red balls and 2 blue balls. You randomly draw 2 balls, one at a time, without replacement. Without replacement, this means we're dealing with the dependent probability or dependent events, or what we call conditional probabilities. What is the probability that you draw at least 1 red ball? Now for the direct approach, we'll have found the probability of having, we are drawing 2 balls, so at least 1 red ball, we can have red, then blue, probability of blue, then red, or probability of red and red. Okay, all this probability then you add. That's the direct approach. Instead of finding out what we want, what don't we want? We don't want a situation where we don't have a red ball. We need to have at least one. And that's the key word, that whenever we find at least, think of it in terms of which is the easier way to look for this, to solve this problem. Do I need to find the direct probability and find all the possibilities for the direct probability and add them, or find the complement, what you don't want, then subtract from the total? So what you don't want in this case is probability of having 2 blue balls. Okay, this is the only thing that we don't want. Probability of having 2 blue balls. All these are what we want. Now we can find probability of having 2 balls, then subtract that from the total. That's 1. So what's the probability of having 2 balls? For the first pick without replacement, we have 2 out of 5 balls. And for the second pick, for the second pick, we get another blue ball out of the 4 remaining. We're left with 1 blue ball, and that will be probability. Then and means multiply this together, and you'll have 2 out of 20, which is 1 over 10. That's the probability of having 2 blue balls. This is what you don't want. Now, be careful when you're doing a test, because you'll find the likes of 1 over 10, because these second now, you'll use the complement probability, the complement rule, to solve the question, since you have at least. So you'll find 1 over 10 in the answer choices. Don't be in a rush to pick 1 over 10. Instead, remember to subtract from the total. And the total will be 1 minus 1 over 10. You'll have 9 over 10. That's the answer. What's the probability that you draw at least 1 red ball? That's 9 over 10. You can go ahead and use the direct probability, tackle it, and then share your feedback or answers in the comment section below. So we've looked into the direct probability, we've looked into the probability tree, and now complement probability. What about the combinatorics approach? When do we use the combinatorics approach? This is efficient when you have to pick a number of items from or people from a group. And for this one, is just when you're picking, when you have order selection, depending on if you have order selection or not. We can have this formula used for very difficult questions, especially when you're dealing with also the same picking or choosing a sample from a group. And you have very clear rules when using this. For this ones, since you're talking about picking items or people from a group, then that's when you have the limitation. They not be the best choice or for problems requiring conditional probability. We're dealing with conditional probability. The best way to do that, you can use the probability or direct or indirect or the complement approach. And also, since we're dealing with combinatorics methods, now you don't have that deep understanding. This is even much worse compared to the direct and the complement one. Now we don't have that deep intuition of the probability quotients or the probability fractions, not fractions, but proportions. Now you just deal using formulas, and actually using the formulas in combinatorics, you need to understand how to solve using these combinatorics problems. You just have to be careful solving using these formulas, and don't make errors. It's very easy for you to make errors while cancelling or solving these problems using this combinatorics approach. And lastly, you can't visualize the problem. You don't have that deep understanding of the problem, and therefore you can't tweak if you find some errors with your approach. You have to follow solid combinatorics approach. The moment you pick values, then you're out. So be careful in choosing your approach depending on what you're dealing with, and whatever you find is convenient to you. Pick the approaches that I've shared. Besides the combinatorics approach, there's also the complement combinatorics approach, which is a variant of the combinatorics approach, but the same idea as the complement probability or the complement role that we've used. Okay, here's the practice question. You can go ahead and give it a try. Since we've not done the combinatorics approach, let's do this example and then see how the combinatorics approach is applied or used for particular questions. So pause the video, give it a try, share your questions in case you have any questions. Please don't hesitate to share your concerns or recommend the next video that we'll be doing. And yeah, subscribe and like the video as well. So we have a company that employs 3 men and 5 women. Right? If a team of 4 employees is to be randomly selected, now you're selecting a team of 4 employees randomly from a company to organize for the company retreat. What's the probability that a team will have exactly 2 women? We're talking about exactly 2 women. Okay, so what's the best way to approach this? First, think of combinatorics. If you say 3, choose 2, think of it in terms of choosing 2. The C meaning choosing. So if you're picking exactly 2 women, we can't pick women from men. We have to pick from the 5 women. Let's choose 2. And then since you need 4 employees to the committee to organize this company retreat, we have to choose the rest that are also men. So we have 2 women that we have exactly 2 women that we chose in this team of 4 employees, or in this committee of 4 employees, so that you can have the rest of the options. That those are 2 options, or 2 men that needs to be chosen from the 3 men. So 3 choose 2 for the men as well. So you can have a team of 4 employees that will be needed to organize for this company retreat. So we choose 2 women from the 5 women and 2 men from the 3 men. All over the number of ways you can choose 4 of these employees from all of the 8 employees, right? This is the total number of possibilities, and this is what we need for the probability that a team will have exactly 2 women, right? So we choose 2 women from the 5 women and 2 men from the 3 men. All over the number of possibilities, you can have this team of 4 employees from all these 8 persons, these men, 3 men and 5 women. And so solving this, 5 choose 2 equals, this is 5 factorial all over 2 factorial 5 minus 2 factorial. This is 5 factorial all over 2 factorial times 3 factorial. If you solve for this, we'll have 10. So let's solve this. This is 5 times 4 times 3 factorial all over 2 factorial. This is 2 times 1 times 3 factorial. Cancel out the 3 factorials and you'll have a factor of 2 here and a factor of 2 here. So you can have 5 times 2, that's 10. 5 choose 2, that's 10. 3 choose 3, choose 2 equals to 3, choose 1, which is 3. This is an combinatorics identity. So I hope you guys get to learn about these identities. You don't have to solve for most of these problems. By using these identities, you can solve yourself a lot of time. And then we have 8 choose 4. This is 8 factorial. 4 factorial, then 8 minus 4, that's another 4 factorial. This is 8 times 7 times 6 times 5 times 4 factorial. Let's expand one. 4 factorial can have 4 times 3 times 2 times 1, but you don't need to add 1, then times 4 factorial. So you can have cancel out 1 for 4 factorial, and then a factor of 4, you can have 2 there, and then 3 times 2, that's 6, cancel out that and have 6 out. So you have 2 times 7 times 5. 2 times 5, that's 10, times 7, that should be 70, right? So we have 5 choose 2 and 3 choose 2. This will be 5 choose 2, that's 10, and 3 choose 2, that's 3, all over 8 choose 4, that's 70, right? So multiply this together, and means multiply. This is 10 times 3 all over 70, and you'll have 30 over 70, which simplifies to 3 out of 7. Yeah, and that the answer is D. I hope you got that question right. And so you all understood these kinds of approaches. We have the combinatorics approach, we have the direct probability, we have the complement rule, and we have the probability tree. Practice on these approaches depending on the question types, depending on the keywords. At least means complement, think of it in terms of the complement, what you don't want, and solve for what you want. We have the probability when you have small level questions, so we don't have multi-stage probabilities or conditional probabilities. And then we have the combinatorics when you're selecting items, and it can be good when you do combinatorics, and for most cases when you're having to choose from a selection of group. So I hope you enjoyed the video. Please like, subscribe and share. feel free to ask any questions in the comment section below. In case you have any concerns or recommendations for the next video, please don't hesitate. Please contact us and we'll gladly look into it and create whatever you want. So thank you all for coming. Have a great day. Bye bye.